Question 16 says, a student is flying a kite. The kite is held in equilibrium by a string as shown. The weight of the kite is 24 Newton and the wind exerts a force of 70 Newton at an angle of 43 degree. So this diagram clearly shows that this 70 Newton is the force from the wind, which acts at an angle of 43 degree. Question says, determine the magnitude of the tension in the string by using a scale vector diagram. We have to focus on scale vector diagram, everybody. So before you draw the scale vector diagram, you don't have to do this in your exam, but if you can imagine what a free body force diagram would look like, it would be much easier for you. So the diagram on the left, this is the one on the left, is the free body force diagram, and the one on the right would be your scale vector diagram. So if you look at this, everybody, you can see this is the force from the wind, this is the weight and the tension. And if you arrange these forces tip to tail, what you end up with is a vector diagram. And the scaling is also very important because the question says scale vector diagram or not just a vector diagram. So the scaling for this question I have taken as 1 Newton representing 1 millimeter. 1 Newton being represented by 1 millimeter. So this is 24 Newton, this is 70 Newton, and when you measure this with your ruler, you will see this is 55 millimeter representing 55 Newton. That's your answer. The next question says, the student wants to determine the tension T in the string. She attaches a mass holder to the string. The student adds known masses to the mass holder until the kite is in equilibrium and part of the string becomes horizontal as shown. So over here, mainly focus on the vertical component of tension. This tension is balancing the weight. So there must be a force over here as well, but that's not very important. The student takes a photograph of the arrangement, and we know, everybody, we can measure angles directly from photographs. So describe how the student can use the photograph to determine T. I have to find out this value of T. And again, back in your mind, always remember, we have to focus on T cos theta because this component of tension is balancing the weight of the mass holder and masses. So the very first thing you do is measure the angle to the vertical using a protractor. Of course, this is done from the photograph. Secondly, calculate the weight of the mass holder using W equals mg. I know the mass, multiplying it with g will give me the weight, and the vertical component of T, which is T cos theta, will be equal to this weight. So vertical component T cos theta is equal to weight. All you have to do is just make T the subject of the equation because you had previously found out the value of theta. So cos theta can be easily calculated.